Before the glow of cities erased the cosmos, humanity lived under a blanket of brilliant stars. For our ancient ancestors, the night sky was not an empty void, but a living tapestry, a divine manuscript written in light. Every sunrise was a promise, every eclipse a warning, and every constellation a character in the epic story of creation. They saw gods and monsters, heroes and villains, all tracing their eternal dance across the celestial sphere. This was more than simple stargazing. It was a profound dialogue with the universe. In the predictable march of the planets, they sought to understand the unpredictable nature of life itself. From the Fertile Crescent to the jungles of Mesoamerica, civilizations rose and fell by the celestial clockwork above. This is the story of how humanity looked to the heavens, not just to find its way in the dark, but to discover its very destiny. Before history was written, before the first cities rose from the dust, there was the night. For early humans, it was a realm of peril, a blanket of blackness punctuated by the familiar glow of a campfire. But above, a spectacle of silent, shimmering light unfolded every evening. For millennia, this celestial display was simply part of the natural world, as unremarkable as the trees or the rivers. Then, something shifted in the human mind. A new awareness dawned. That first conscious gaze upward was a defining moment for our species. It was the birth of wonder. This was not a single event, but a slow, creeping realization that stretched over thousands of years. Early hunter-gatherers, whose very survival depended on understanding the patterns of the world around them, began to notice the rhythms of the sky. The sun's daily journey brought warmth and light. The moon's changing shape marked the passage of nights in a predictable cycle. These were the first clocks, the first calendars. The appearance of certain star groups heralded the changing of seasons, signaling when animal herds would migrate or when certain plants would bear fruit. The sky was not just beautiful, it was useful. It was a guide to survival, a map written in points of light. In the deep, ancient caves of Lascaux in France, we find tantalizing hints of this awakening. Painted over 17,000 years ago, magnificent depictions of bulls, horses, and deer cover the walls. For decades, they were seen purely as hunting art or shamanic visions. But some researchers now see a second layer of meaning. A cluster of dots above the shoulder of a bull bears a striking resemblance to the Pleiades star cluster. The bull itself, with a pattern of dots near its eye, mirrors the constellation we call Taurus. Could these early artists have been painting not just the world they saw on the ground, but the one they saw in the heavens? Was this the first star map, an attempt to connect the spiritual power of the animals with the cosmic order above? Further north, in what is now Scotland, a more direct piece of evidence was unearthed at Warren Field. Here, around 10,000 years ago, Mesolithic people dug a series of 12 pits. These pits are arranged in an arc that appears to track the phases of the moon across a full year, even correcting for the slight discrepancy between the lunar and solar calendars. It is the oldest lunar calendar ever discovered. It was a monumental effort, a way to anchor the fleeting cycles of the moon to the solid Earth. Humanity was no longer just a passive observer of the cosmos. They were beginning to measure it, to predict it, to engage with it. It was not enough to simply watch the sky. Soon, a new compulsion would arise, to capture its power, to mirror its celestial dance in stone, and to build monuments to the heavens themselves. The compulsion to connect with the heavens drove humanity to an extraordinary new endeavor, shaping the very landscape. Across the ancient world, a revolution in stone began. People started to raise enormous monuments, known as megaliths, with a purpose that went far beyond shelter or defense. These were instruments of connection, built to align with the sun, the stars, and most importantly, the moon. With the dawn of agriculture, Tracking the seasons became a matter of life and death. But it was the moon, with its rapid and easily observed cycle, that served as humanity's first and most intimate timekeeper. In Ireland's Boyne Valley, an immense green mound rises from the landscape. This is Newgrange, built around 3200 BCE, making it older than the pyramids of Giza and Stonehenge. For centuries, its true purpose was a mystery. We now know it as a masterpiece of Neolithic engineering and astronomy. A long, narrow passage leads to a central chamber deep within the mound. For most of the year, it remains in complete stillness. But on the winter solstice, the shortest day of the year, a special opening above the entrance allows the first rays of the rising sun to pierce the inner sanctum, flooding the chamber with light for 17 minutes. It is a stunning solar alignment. Yet, Newgrange holds lunar secrets as well. The intricate geometric carvings that adorn its entrance stone are believed by some to be symbolic representations of lunar cycles and eclipses. It was a place where the two great lights of the sky, sun, and moon were honored in equal measure. This lunar fascination was not unique to Ireland. On the Isle of Lewis in Scotland, the Callanish stones stand in a hauntingly beautiful arrangement, a central circle with avenues of stones radiating outward. While their exact purpose is still debated, compelling theories suggest they form a complex astronomical observatory, with key alignments pointing to the southern moonrise at a very specific time, the major lunar standstill. This is a far more complex cycle than the solar year. The moon's rising and setting points on the horizon shift over an 18.6-year period. To build a monument that accurately tracks the extreme points of this long, slow cycle demonstrates a level of sustained observation and generational knowledge that is simply astounding. These were not primitive people. They were patient, meticulous observers of the heavens who encoded their profound understanding into these enduring stone structures. These silent stones tracked the moon with a precision that baffles us still. But were they merely timekeepers, or were they something more profound? Were they stages for rituals designed to commune with the forces that governed their world, places where the whispers of the cosmos could finally be heard? Of all the enigmatic structures built by ancient hands, one name echoes through the ages: Stonehenge. On the Salisbury Plain in England, these colossal stones stand as a testament to the ambition and celestial focus of Neolithic people. For over 1,500 years, from roughly 3,000 to 1,500 BCE, generations labored to build and rebuild this monument. The largest stones, weighing up to 40 tons, were dragged over 20 miles. The smaller bluestones came from over 150 miles away in Wales, an almost unbelievable feat of transport and engineering. Why? The answer, we know, lies in the sky. Stonehenge is a marvel of solar alignment. On the summer solstice, the longest day of the year, the rising sun appears to emerge directly over the heelstone, sending a ray of light into the heart of the circle. On the winter solstice, the setting sun aligns perfectly between the uprights of the tallest trilithon. It was a calendar, yes, but to call it only that is to miss its soul. This was not a tool for farmers to simply know when to plant crops. The sheer scale of the effort suggests a far deeper, more sacred purpose. This was a cathedral of the sun, a place of immense spiritual importance. Thousands of people would have gathered here on those special days, participating in ceremonies that celebrated the turning of the great cosmic wheel, the eternal cycle of light and life. And Stonehenge was not alone. It was the heart of a vast ceremonial landscape. Nearby, the Avebury Stone Circle, so large it encompasses an entire village, suggests that these celestial rituals were a widespread and central part of life. These were not just observatories, they were theaters for the human drama. They were places where communities came together, where ancestors were honored, and where the connection between the earthly and the celestial was made real. The alignment of the stones was the stage setting. The rituals performed within them were the main event. We can imagine processions, chants, and offerings, all timed to the precise moment a celestial body reached its mark. The sky was not just observed, it was actively engaged with. It was a partner in the spiritual life of the community. The people of the stone circles left no written record of their beliefs. Their cosmic story is etched only in earth and rock, leaving us with more questions than answers. What did they believe about the sun and moon? Did they see them as deities, as ancestors? We can only speculate, listening to the faint whispers carried on the wind that blows across the plains. But far away, in the fertile plains between two rivers, a new kind of civilization was rising. They would not only watch the stars, they would write down what they saw, and in doing so, they would transform the heavens from a map of seasons into a divine script, written by the gods themselves. In the land between the rivers, Mesopotamia, the sky was not a mystery to be solved, but a message to be read. Here, in the cradle of civilization, the Sumerians, Akkadians, and Babylonians developed a profoundly different relationship with the cosmos. For them, the heavens were alive. The sun, moon, and the 5 visible planets were not just celestial objects. They were the physical manifestations of their most powerful gods, striding across the night sky. The brilliant Venus was Ishtar, the goddess of love and war. The red glow of Mars was Nergal, the god of plague and the underworld. The majestic Jupiter was Marduk, the king of the gods himself. This belief transformed the sky into a divine drama. The movements of these celestial beings were not random. They were omens, communications from the gods concerning the fate of humanity, and most importantly, the fate of the king and the state. An eclipse, a meteor shower, the position of a planet in a certain constellation, all held meaning. To decipher these messages was to know the will of the gods. Astronomy and religion were inseparable. On top of their towering ziggurats, which reached toward the heavens, priest astronomers spent their nights in meticulous observation. They were not simply charting the stars, they were spying on the gods, trying to learn their plans. Over centuries, they accumulated a vast and systematic body of knowledge. They created detailed star catalogs, mapping the constellations and the path the planets traveled through them, which they called the zodiac. They developed sophisticated mathematical techniques that allowed them to predict the movements of the moon and planets with remarkable accuracy. They could forecast lunar and solar eclipses, events that were seen as particularly potent omens. But this was not science for the sake of knowledge. It was a vital tool of government. The chief astronomer was one of the most important officials in the royal court. His interpretations of celestial events could influence military campaigns, the construction of temples, and the very stability of the kingdom. Every observation was recorded on clay tablets in cuneiform script, creating an immense archive of celestial data. This was the birth of organized written astronomy. The Babylonians established the fundamental principles that would be passed down for millennia: the division of the circle into 360 degrees, the concept of the zodiac, and the belief that earthly events were linked to heavenly ones. For the Mesopotamian kings, the sky was a battlefield of divine wills, a constant stream of warnings and promises. To ignore them was to court disaster. The priest astronomers became the most powerful advisors in the kingdom, for they held the key to deciphering this celestial script. They collected their knowledge, their predictions, and their fears onto clay, creating a library of cosmic law that would dictate the rise and fall of empires, the tablets of destiny. It is not made of gold or precious gems, but of simple clay. Yet this humble object held more power than any crown. For the kings of Babylon and Assyria, the cuneiform tablet was a direct line to the will of the gods, a guide to navigating the perilous currents of fate. The collected knowledge of generations of skywatchers was compiled into a monumental work, a vast library of celestial omens known as the Enuma Anu Enlil. It contained thousands of entries, each a conditional statement linking a celestial event to an earthly outcome. If the moon is surrounded by a halo and Jupiter stands within it, the king of Akkad will be besieged. If Venus disappears in the east in the month of Ajaru, there will be weeping and wailing in the land. This was mundane astrology, concerned with the fate of the nation, the king, and the harvest. The life of an ordinary person was not considered significant enough to warrant a divine message. The system was based on observation and historical precedent. If a strange red halo appeared around the moon and a battle was lost shortly thereafter, the event was recorded. The next time that halo appeared, it was taken as a warning of impending military defeat. The priest astronomers were pattern seekers, poring over their vast archives to find correlations between heaven and earth. Their job was to advise the king on how to react, what rituals to perform to appease the gods and avert a foretold disaster. The pressure was immense. A missed omen or a faulty interpretation could lead to catastrophe, and the consequences for the astronomer could be severe. Perhaps nothing illustrates the deadly seriousness of this practice more than the ritual of the substitute king. A lunar eclipse was considered one of the most dangerous omens, often foretelling the downfall of the monarch. If such an eclipse occurred and was deemed unavoidable, a desperate plan was enacted. A commoner, or sometimes a captive, would be officially installed on the throne as a substitute. He would be given the royal robes, live in the palace, and for a short time be treated as the king. The hope was that he would absorb the divine wrath intended for the true ruler. Once the danger period had passed, the substitute was removed from his position, and the real king would resume his duties. The fate of the substitute was final. This extreme measure shows that for the Mesopotamians, the omens were not metaphors. They were tangible threats that required immediate and drastic action. The Mesopotamians laid the foundation. They transformed the stars from distant lights into active participants in the human drama, creating a system of belief that saw destiny written in planetary motion. Their clay tablets, filled with warnings and prophecies, would be copied, studied, and carried across the ancient world. This profound idea, that our lives are connected to the cosmos, would be inherited by the philosophers of Greece and the mystics of Egypt, who would take this celestial science and shape it into the astrology we know today, forever changing humanity's relationship with the stars above. In the stark, sun-drenched landscape of ancient Egypt, one celestial body reigned supreme. Not the moon, nor the distant stars, but the sun itself. It was the source of all life, a daily miracle of fire and light. This was Ra, the creator god, who sailed across the sky in his solar bark, battling the serpent of chaos each night, only to be reborn, victorious, every single dawn. His journey was the ultimate symbol of Mayat, the fundamental concept of order, truth, and cosmic balance. And on earth, there was one man whose entire existence was dedicated to upholding this divine order: the Pharaoh. He was not merely a king, he was the son of Ra, a living god whose duty was to ensure that the harmony of the heavens was reflected in the kingdom of Egypt. This sacred duty was literally built into the landscape. The grand temples were not just places of worship, they were cosmic engines, their pylons representing the horizon, their halls charting the sun's daily path. The great pyramids at Giza, monuments of breathtaking precision, were aligned to the cardinal points with an accuracy that remains astonishing. Their internal shafts were aimed like telescopes at specific stars, creating pathways for the king's soul to ascend to the heavens and join the imperishable ones, the circumpolar stars that never set. The pharaoh's connection to the cosmos was a source of immense power, a piece of political theater on a celestial scale. At Abu Simbel, the great temple of Ramesses II, this relationship was made brilliantly clear. Twice a year, on the approximate dates of his accession and birth, the first rays of the rising sun pierced the temple's deep darkness, navigating a 60-meter-long hall to illuminate the statues of the gods, and most importantly, the statue of Ramesses himself. It was an undeniable statement. The king was one with the gods, sanctioned by the sun itself. This mastery extended to the measurement of time. The Egyptians developed a solar calendar of 365 days, a model of efficiency and accuracy. Its beginning was marked by the heliacal rising of the star Sirius, or Sopdet, an event which also heralded the life-giving annual flood of the Nile. To control the calendar was to control the planting and harvesting seasons, the religious festivals, the entire rhythm of Egyptian life. The pharaoh's authority was not just decreed, it was written in the stars, a celestial mandate that fused religion, science, and power into a single unified vision of cosmic order. For the ancient Egyptians, life on earth was but a prelude. Death was not an end, but a transition, a perilous journey toward an eternal existence among the stars. The ultimate goal was to become an Akh, a transfigured and effective spirit, whose rightful place was in the night sky. But this celestial paradise was not easily won. The path was fraught with challenges, a cosmic landscape that the soul had to navigate with wisdom and courage. To aid them, the Egyptians created funerary texts, collections of spells and incantations we now call the Book of the Dead. These were not books in the modern sense, but personalized guidebooks for the afterlife, inscribed on papyrus scrolls and tomb walls. They provided the essential knowledge needed to pass through the gates of the underworld, to name the divine guardians, and to overcome the trials that awaited. The destination for the most revered souls, especially the pharaohs, was a specific region of the heavens, the circumpolar stars. Known as the indestructibles or the imperishables, these stars never dipped below the horizon, making them perfect symbols of eternity. To join them was to achieve true immortality. The constellation we know as Orion held a place of special importance. The Egyptians saw it as the celestial form of Osiris, the god of the afterlife, resurrection, and fertility. His own myth, a story of a good king overcome by his brother and brought back to life by his devoted wife, Isis, was the divine prototype for every soul's journey. The stunning alignment of the three great pyramids at Giza with the three stars of Orion's belt was no accident. It was a terrestrial effort to create a direct path for the pharaoh's soul to unite with the great god in the sky. The entire cosmos was personified as a divine being, most notably the sky goddess, Nut. Often depicted as a woman whose star-covered body arches over the earth, she was the celestial mother. Each evening, she swallowed the sun god Ra, who traveled through her body during the night to be reborn from her at dawn. The deceased hoped for a similar rebirth, to pass through the cosmic mother and emerge as a star in her celestial embrace. But before this glorious rebirth, every soul faced a final judgment, the weighing of the heart. In the Hall of Two Truths, the deceased's heart was placed on a scale, balanced against the single feather of Ma'at, the goddess of truth and order. For the Egyptians, the night sky was more than a calendar or a collection of myths. It was the final destination, a map to eternity. In the early world of the ancient Greeks, the heavens were a grand stage for divine drama. The sun was the fiery chariot of the god Helios, the moon his sister Selene. The constellations told epic tales of heroes, gods, and monsters, Perseus slaying the Gorgon, Hercules performing his labors, Orion the hunter forever pursuing the Pleiades sisters. These were stories rich with cultural meaning, moral lessons, and explanations for the world's creation. They were powerful myths, but they were not science. Then, in the 6th century BCE, on the coast of Ionia in modern-day Turkey, a revolution in human thought began. A group of thinkers, known as the Pre-Socratics, started asking a profoundly new kind of question. Not who controls the heavens, but what are the heavens made of? They sought natural, not supernatural, explanations for the phenomena they observed. Thales of Miletus, often called the first philosopher, famously used his knowledge of Babylonian astronomy to predict a solar eclipse in 585 BCE. The event, which halted a battle, was a stunning demonstration that the movements of the heavens were not the arbitrary whims of gods, but predictable, regular cycles governed by understandable rules. His student, Anaximander, went even further. He proposed a radical model of the cosmos, where the Earth was a cylinder, floating unsupported in the center of the universe. He imagined the sun, moon, and stars were not gods, but rings of fire, seen through holes in the celestial fog. Though his model was wrong, the approach was revolutionary. It was a mechanical explanation, an attempt to build a physical model of the universe. This intellectual fire culminated in the figure of Pythagoras. For him and his followers, the key to the universe was not a substance like water or fire, but something more abstract: number. They discovered that musical harmonies could be expressed as simple numerical ratios. This led them to a profound conclusion. If music was mathematics made audible, then the cosmos itself must be mathematics made visible. The universe, they believed, was a cosmos, a word that for the Greeks meant not just universe, but also order and beauty. The planets, moving at different speeds in their orbits, must produce a magnificent, unheard harmony, the music of the spheres. This was the Greek miracle. In a few short centuries, they had shifted the human perspective from a universe run by capricious deities to one governed by elegant, impersonal, mathematical law. The goal of the wise was no longer simply to appease the gods, but to comprehend the rational structure of the cosmos itself. The stars were no longer just characters in a story. They were points in a grand geometric puzzle, waiting for the human mind to solve it. In the intellectual heart of 4th century Athens, within the groves of Plato's academy, the greatest minds of the age wrestled with a cosmic puzzle. While the fixed stars moved with perfect regularity, a handful of celestial bodies refused to cooperate. These were the planets, the wanderers, whose looping backward motions seemed to defy the elegant order the Greeks had come to expect from the heavens. How could this apparent chaos be reconciled with a rational universe? The answer, for Plato, lay not in observation alone, but in philosophy. Plato taught that the physical world we perceive with our senses is a flawed, imperfect shadow of a higher reality, a world of perfect, eternal forms. True reality is not the chair you sit on, but the perfect idea of chairness. For him, this principle extended to the entire universe. In his influential dialogue, the Timaeus, Plato describes the cosmos as the handiwork of a benevolent craftsman, the demiurge. This divine artisan did not create the universe from nothing, but shaped pre-existing matter by looking to the perfect, unchanging forms as his blueprint. The result was a cosmos that was not a dead machine, but a single, living, intelligent being with a soul and a purpose. At the center of this cosmic animal was a stationary, spherical Earth. Revolving around it were a series of vast, transparent, crystalline spheres. The closest carried the Moon, then Mercury, Venus, the Sun, Mars, Jupiter, and Saturn. The final, outermost sphere held all the fixed stars. This was a universe of sublime geometric perfection. But for Plato, it was more than just geometry. Drawing on the ideas of the Pythagoreans, he argued that as these great spheres turned, they produced a sound. Each sphere, moving at its own unique speed, determined by perfect mathematical ratios, generated a specific musical note. Together, they created a magnificent, continuous celestial chord, the harmony of the spheres. This cosmic music was the very sound of reason and order. We mortals cannot hear it, Plato suggested, only because we have been immersed in its sound since the moment of our birth. This vision was profoundly influential. It wasn't just a scientific model intended to predict planetary positions. It was a moral and aesthetic framework. The purpose of human life, in the Platonic view, was to bring the chaos of one's own soul into harmony with the perfect, rational order of the cosmos. Through the study of philosophy, mathematics, and astronomy, one could attune their inner world to this divine music. Plato's geocentric model of nested spheres would dominate Western thought for nearly 2 millennia, a testament to its philosophical power and elegance. He gave the world a universe that was not just orderly, but beautiful, meaningful, and divine. As our planet makes its annual journey around the sun itself appears to travel across a fixed backdrop of stars. This celestial highway, known as the ecliptic, became the focus of intense scrutiny for the ancient world's most dedicated skywatchers. It was in ancient Mesopotamia, among the priest astronomers of Babylonia, that this path was first systematically mapped and divided. Over centuries of meticulous observation, they identified the constellations that lay along the sun's path, and, around the 5th century BCE, they organized them into a system that would echo through history. They divided the 360-degree circle of the ecliptic into 12 equal segments of 30 degrees each. The number 12 was practical, aligning with their base 60 counting system and the approximate number of lunar cycles in a solar year. To each segment, they assigned a signature constellation, creating a celestial belt, a great circle of little animals. This was the birth of the zodiac. For the Babylonians, however, this was not about reading a daily horoscope in the back of a scroll. It was a tool of mundane astrology, a form of cosmic intelligence gathering for the state. The heavens were a divine tablet on which the gods wrote their intentions for the kingdom. The position of Jupiter, the planet associated with their chief god Marduk, in the constellation of the Lion, might signal a prosperous period for the king. A lunar eclipse in the scales could portend famine or unrest. The fate of the nation, not the individual, was read in the stars. This powerful system traveled west with the conquests of Alexander the Great. The Greeks, with their appetite for new ideas, were captivated. They adopted the 12-part division and the constellations, but they reclothed them in the rich tapestry of their own mythology. The Babylonian hired man became Ares, the ram with the golden fleece. The great twins were reborn as Castor and Pollux, the heroic brothers of Helen of Troy. The celestial menagerie was given a new, dramatic cast of characters. It was in the cosmopolitan world of Hellenistic Egypt, however, that the zodiac underwent its most profound transformation. In a society where the individual was gaining new importance, astrology turned its gaze from the fate of kings to the destiny of common people. The idea of the horoscope, from the Greek horoskopos, or hour watcher, was developed. The belief took hold that the unique configuration of the sun, moon, and planets within the 12 zodiacal signs at the very moment of a person's birth shaped their character, their potential, and their destiny. The zodiac was no longer just a national calendar or a divine warning system. It had become a personal mirror, a celestial map of the human soul, a powerful and enduring idea that connected the inner life of every individual to the grand, sweeping cycles of the cosmos. In the sprawling, marble-clad heart of the Roman Republic, a new power was rising, not from the legions or the Senate, but from the East. Astrology, inherited from the Babylonians and refined by the Greeks, arrived in Rome as a potent and dangerous form of knowledge. It promised to unveil the future, a promise that was irresistible to a society built on ambition and obsessed with destiny. For the men who would become emperors, it was a tool of immense power. The first to truly harness its force was Augustus. He didn't just consult astrologers, he weaponized the stars for his own political narrative. He minted coins bearing the symbol of Capricorn, his sun sign, tying his personal destiny to the greatness of Rome itself. The message was clear. His rule was not a matter of chance, but was written in the heavens. This celestial endorsement helped solidify his authority over a populace that was increasingly captivated by this cosmic science. But as the empire grew, so did the paranoia of its leaders. The same stars that could legitimize a ruler could also predict his downfall. Emperor Tiberius, a successor to Augustus, was a devoted student of astrology, yet he lived in constant fear of its predictions. On the island of Rhodes, he kept the astrologer Thrasyllus by his side, a relationship built on a knife's edge of trust and suspicion. Tiberius would famously test the astrologers he consulted, and any who failed to impress him with their foresight faced a grim fate. Thrasyllus survived by cleverly predicting the emperor's own suspicious intentions. This deep-seated fear reached its peak with later emperors like Domitian. For him, the sky was not a source of guidance, but a gallery of potential threats. He saw conspiracies in every constellation and rivals in every horoscope. The practice of astrology became a capital offense if it concerned the emperor's life. Astrologers who dared to cast the emperor's chart or predict his future were hunted down. The stars had become a double-edged sword, a symbol of divine right for the emperor, but a silent, ever-present threat that could empower his enemies and fuel his own deepest anxieties. While the emperors of Rome wrestled with the celestial portents of their personal fates, the sky above the empire served a far broader purpose. It was a practical guide, a public clock, and a divine map for millions. For the farmer tending his olive groves in Hispania or his wheat fields in Egypt, the rising and setting of specific constellations were a more reliable calendar than any official decree. The appearance of the Pleiades signaled the time for harvest, while the position of Arcturus guided the autumn planting. This was an ancient, terrestrial wisdom, woven into the fabric of daily life across the empire's vast agricultural backbone. For the legions, the sky was the ultimate navigational tool. As soldiers marched across unfamiliar terrain, from the misty forests of Germania to the arid deserts of Syria, the North Star was their constant, unwavering guide. Roman sailors, plying the trade routes of the Mediterranean, looked to the heavens to plot their course, their fortunes dependent on a clear night and a steady celestial bearing. The Roman state, recognizing the power of a shared sense of time, brought the heavens into the city square. Under Julius Caesar, the old, inaccurate lunar calendar was reformed into the solar calendar that we still use today, a monumental effort to align human time with cosmic time. Grand structures like the Horologium of Augustus, a colossal sundial in the Campus Martius, used an Egyptian obelisk as its pointer. It was a public spectacle, a daily demonstration of the emperor's power to organize not just the world of men, but the passage of the sun itself. As knowledge of the zodiac spread, personal horoscopes became immensely popular among ordinary citizens, offering a sense of control and understanding in an uncertain world. But this popularization of celestial knowledge was a concern for the state. If anyone could read the future, the emperor's unique connection to the divine was diluted. This led to periodic crackdowns, with official decrees expelling astrologers from the city of Rome. The state sought to maintain a monopoly on interpreting the heavens, understanding that whoever controlled the sky controlled the narrative of the empire. Deep within the jungles of Mesoamerica, the Maya civilization was engaged in a profound dialogue with the cosmos. Their understanding of time and celestial mechanics was so advanced that it continues to astonish modern astronomers. This was not merely stargazing, it was a sacred science, the very foundation of their society, religion, and power structure. At the heart of their system was an intricate web of interlocking calendars. The 260-day Tzolk'in, or sacred calendar, was combined with the 365-day Hab, a solar calendar, to create a 52-year cycle. But their vision of time extended far beyond this. They conceived of the long count, a monumental calendar that tracked time from a mythical creation date, stretching thousands of years into the past and future. For the Maya, time was not a straight line, but a series of immense, repeating cycles. The end of one great cycle was not an apocalypse, but a moment of cosmic renewal. Maya priests and scribes were the masters of this knowledge. In observatories like the Caracol at Chichen Itza, they made astonishingly precise calculations. They determined the length of the solar year with incredible accuracy and charted the complex movements of the moon and planets. They were particularly obsessed with the planet Venus, which they identified with Kukulkan, their feathered serpent deity. They understood its synodic period, the 584 days it takes to reappear in the same spot in the sky, and knew that its cycles were linked to periods of conflict and ritual. The timing of battles, the coronation of kings, and major religious ceremonies were all dictated by the position of Venus. This celestial knowledge was recorded in beautifully illustrated books called codices. These were the sacred texts of Maya astronomers, containing tables that could predict solar and lunar eclipses with remarkable precision. To witness an eclipse was to see the cosmos in turmoil, a moment of profound spiritual importance that had to be navigated by the king, the divine intermediary between the earthly and celestial realms. Theirs was a universe in constant motion, and survival depended on understanding its sacred rhythms. For the Maya, the night sky was not a collection of distant, unrelated points of light. It was a vibrant, living canvas, the realm of gods and ancestors, and a place of immense power. Central to this cosmic vision was the serpent. This was not an earthly creature, but a divine being, a conduit between worlds. The vision serpent was a mystical entity that appeared in the rituals of Maya kings. Through intense ceremonies, the ruler would open a portal to the supernatural realm, and from this portal, the serpent would emerge, its mouth delivering an ancestor, or a god, who would offer guidance. This powerful symbol had a direct celestial counterpart, the Milky Way. As our galaxy arches across the night sky, the Maya saw it as the great world tree, or the cosmic serpent itself, a shimmering bridge to the heavens. The alignment of their most sacred buildings was a testament to this belief. They were not just places of worship, but cosmic engines designed to interact with the sky. The city of Chichen Itza provides the most stunning example. The Temple of Kukulkan is a masterwork of celestial architecture. Twice a year, on the spring and autumn equinoxes, a remarkable event unfolds. As the sun sets, its rays create a play of light and shadow along the northern staircase, forming the illusion of a massive serpent slithering down the side of the pyramid. This was a public display of the ruler's divine connection. He was not just a king, he was a master of cosmic time, a figure powerful enough to summon the feathered serpent from the sky itself. This moment reaffirmed the king's legitimacy and the divine order of the state. Other alignments were just as critical. The placement of windows in observatories and temples precisely framed the rising and setting points of Venus or the sun on the solstice. These were not coincidences. They were the result of centuries of meticulous observation and sophisticated mathematics, an immense intellectual investment to ensure that the human world remained in perfect harmony with the divine patterns of the cosmos. The serpent in the sky was a constant reminder that for the Maya, heaven and earth were not separate realms, but part of a single, sacred, and interconnected reality. In imperial China, the emperor was known as the Son of Heaven. This was more than a title. It was a sacred contract. He ruled with the divine approval of the sky, a concept known as the mandate of heaven. But this mandate was not permanent. It had to be constantly earned, and the sky itself was the ultimate judge of the emperor's virtue and competence. A clear and predictable sky, with the sun, moon, and stars all following their proper paths, signified a harmonious empire under a righteous ruler. But any deviation from this celestial order, a solar eclipse, a comet blazing across the night, or the sudden appearance of a guest star like a supernova, was interpreted as a powerful and dangerous omen. It was a sign that the emperor's connection to the heavens was weakening, a warning that the mandate could be withdrawn. This belief transformed astronomy into an essential tool of statecraft and an issue of the highest national security. To monitor the heavens, the emperor established the Imperial Astronomical Bureau. This was an elite, secretive institution, staffed by some of the most brilliant scholars in the empire. Their duty was singular and relentless: to watch the sky, record every phenomenon, and interpret its meaning for the emperor alone. Their findings were classified, for if a negative prediction became public, it could spark rebellion among a populace that believed the sky was turning against the dynasty. The pressure on these imperial astronomers was immense. They built magnificent observatories, equipped with enormous and beautiful bronze instruments like armillary spheres and celestial globes, to chart star positions with unparalleled accuracy. Their meticulous, centuries-long records are a treasure for modern science. They documented the 1054 supernova that created the Crab Nebula and recorded every passage of Halley's Comet for over 2 millennia. A correct prediction, such as for a solar eclipse, allowed the emperor to perform the appropriate rituals to symbolically rescue the sun, showcasing his power and restoring cosmic harmony. A failed prediction, however, was a disaster. It could be seen as a sign of heavenly displeasure, and the astronomer responsible could face severe consequences for his failure. In the Forbidden City, the Son of Heaven may have been the most powerful man on earth, but he and his entire dynasty ruled at the pleasure of the silent, ever-watchful stars above. In the heart of the Middle Kingdom, the celestial and terrestrial realms were inextricably linked. The emperor, known as the Son of Heaven, did not rule by birthright alone, but by a divine right known as the mandate of heaven. This was not a permanent contract, but a sacred trust that could be revoked. The arbiters of this trust were the stars themselves. The night sky was a celestial government, a perfect mirror of the imperial court on earth. The pole star, unmoving and eternal, was the emperor. The surrounding circumpolar stars were his family and most trusted advisors. The rest of the glittering cosmos was his vast bureaucracy. Any disruption in this perfect celestial order was a dire warning. An unexpected comet, a guest star suddenly blazing in a familiar constellation, or the terrifying spectacle of a solar eclipse. These were not mere astronomical events. They were messages from the heavens, cosmic memoranda suggesting that the emperor's virtue was failing and his mandate was in jeopardy. To ignore such signs was to invite disaster, famine, floods, and rebellion. To maintain this celestial harmony, the emperor employed an elite cadre of imperial astronomers. Their duty was one of the most critical in the empire. From towering observatories, they meticulously mapped the heavens, charted the movements of the planets, and maintained the official calendar. Their work was a fusion of science and statecraft. An accurate calendar was essential for agriculture, but more importantly, it was a symbol of the emperor's control over time and his alignment with cosmic forces. A miscalculation, a failed prediction of an eclipse, was not just a scientific error, it was a political crisis, suggesting the Son of Heaven was out of touch with his celestial father. The historical records kept by these skywatchers were unparalleled in their precision and longevity. When a brilliant new star appeared in 1054, Song dynasty astronomers recorded its position, its brightness, and how long it remained visible. They were documenting the supernova that created the Crab Nebula, a celestial event that would have been interpreted as a powerful and perhaps unsettling omen for the reigning emperor. For centuries, the fate of dynasties was written in the sky. An emperor who ruled with wisdom and justice would see the heavens remain stable and predictable. But a ruler who became corrupt or incompetent would be warned by celestial portents, signs that the mandate of heaven was being withdrawn, opening the door for a new dynasty to claim its rightful place under the watchful eyes of the stars. The Pacific Ocean is a realm of immense scale, a blue continent covering 1/3 of the planet's surface. Scattered within its vastness are thousands of islands, separated by seemingly impossible distances of open water. For centuries, Western explorers were baffled. How did ancient peoples, without sextants, compasses, or written charts, not only find these tiny specks of land, but purposefully travel between them? The answer lies in one of the most sophisticated systems of navigation ever developed, the art of wayfinding. This was not merely following a single star. It was a holistic science, a deep communion with the natural world, where the canoe, the navigator, and the cosmos became one. At the heart of this system was the star compass. A master navigator, or PWO, memorized the rising and setting points of over 200 stars. The canoe itself was the center of this living compass. By keeping a specific rising star off the bow and a corresponding setting star at the stern, the wayfinder could hold a precise course through the darkest night. This knowledge was sacred, passed down through generations via epic chants and complex tactile maps made from shells and sticks, which represented islands, currents, and swell patterns. The training began in youth, forging an unbreakable bond between the student and the sky. Latitude was determined with elegant simplicity. The navigator would track a star that passed directly overhead at his home island. When traveling north or south, he knew he had reached the correct latitude of his destination when a different, predetermined star was directly overhead at its zenith. The height of familiar stars above the horizon, measured with the width of a hand held at arm's length, also served as a reliable guide. But the stars were only part of the story. The wayfinder was attuned to the subtlest clues of the ocean. They learned to read the language of the waves, feeling the deep ocean swells that moved consistently from distant storm centers. As these swells passed and refracted around an island, they created distinct patterns that a skilled navigator could feel in the hull of the canoe, signaling the presence of land long before it was visible. They followed the flight paths of birds that nested on land but fed at sea, and they understood how the shapes of clouds could indicate a landmass just over the horizon. This was a system of total immersion, of profound observation and memory. It enabled the Polynesians to undertake the greatest voyages of human expansion in history, settling the remote corners of the Pacific, from Hawaii to Easter Island to New Zealand. They did not drift aimlessly. They sailed with purpose, their path guided by a map written in starlight. In ancient India, the universe was not a random collection of objects, but a manifestation of Urta, the principle of cosmic order and truth. The sun's daily journey, the moon's phases, and the predictable march of the planets across the sky were seen as the rhythms of a divine, self-regulating system. To understand these rhythms was to understand the very nature of existence. This pursuit of celestial knowledge was formalized in the Jyotisha, or the science of light, one of the essential disciplines required to understand the sacred Vedic texts. While many cultures looked to the sun's path through the 12 constellations of the zodiac, Indian astronomers developed a parallel and equally important system, the nakshatras. This was a lunar zodiac, dividing the moon's monthly journey into 27 distinct sectors, or lunar mansions. Each nakshatra was associated with a specific star, a ruling deity, and a set of symbolic meanings. This system provided a much finer-grained celestial clock used to determine the most auspicious moments for every significant life event, from planting crops to conducting a marriage ceremony or commencing a journey. It was a practical guide for living in harmony with the cosmos. This spiritual cosmology was accompanied by a remarkably advanced mathematical astronomy. By the 5th century CE, the astronomer Aryabhata presented revolutionary ideas. He correctly argued that the Earth was a sphere that rotated on its own axis, creating the illusion of a spinning sky. He proposed a model where the planets orbited the Sun, and he provided sophisticated explanations for solar and lunar eclipses, dismissing older myths of celestial demons. His calculation for the length of the solar year is astonishingly close to the modern value. Centuries later, scholars like Varahamihira compiled vast encyclopedias that blended predictive astronomy with astrology, meteorology, and architecture, showing how deeply the study of the stars was integrated into all facets of society. Indian cosmology also operated on a scale of time that dwarfed other ancient worldviews. The concept of the yugas described immense cycles of creation and dissolution, vast cosmic ages lasting millions of years. The movements of the planets were the hands on this grand cosmic clock, ticking away the moments of immense epochs. The stars were more than just lights in the sky. They were the visible gears of a divine machine, a source of profound mathematical inquiry, and a spiritual guide whose influence shaped the destiny of every individual from the moment of their birth. In the wake of Alexander the Great's conquests, a new city rose on the coast of Egypt that would become the intellectual capital of the ancient world. Alexandria was a vibrant crossroads of cultures, and at its heart stood a revolutionary institution, the Great Library. More than a mere collection of scrolls, it was a center for research and a melting pot of ideas. Here, for the first time, the astronomical knowledge of the ages was gathered under one roof. The meticulous, centuries-old observational records of Babylon were placed alongside the geometric proofs of the Greeks and the calendrical wisdom of the Egyptians. This synthesis of theory and data ignited an unprecedented period of discovery. The scholars of Alexandria were not content to simply preserve knowledge, they sought to build upon it. The library's chief librarian, Eratosthenes, performed a legendary experiment. Hearing that on the summer solstice, the sun shone directly down a well in the southern city of Syene, he measured the length of a shadow cast by a stick in Alexandria on the same day. Using the difference in angle and the known distance between the two cities, he calculated the circumference of the Earth. His result was remarkably accurate, a triumph of human reason and observation. Another brilliant mind associated with the city, Aristarchus of Samos, put forth an even more radical idea. By observing the Earth's shadow on the moon during an eclipse, he deduced that the sun must be vastly larger than the Earth. To him, it seemed logical that the smaller body should orbit the larger one. He proposed a heliocentric model of the solar system, placing the sun at the center. His theory was too far ahead of its time and was largely dismissed for nearly 2,000 years. The work continued with Hipparchus, who, though not based in Alexandria, relied heavily on the data it housed. He painstakingly catalogued over 850 stars, inventing a magnitude system to rank their brightness that we still use today. By comparing his charts with older Babylonian records, he made a startling discovery: the slow, conical wobble of the Earth's axis, a phenomenon known as the precession of the equinoxes. Later, in the 2nd century CE, Claudius Ptolemy, working in Alexandria, would synthesize all this knowledge into his masterwork, the Almagest. His intricate geocentric model, with the Earth at the center, was so mathematically compelling that it would dominate astronomical thought for the next 1400 years. The eventual decline and destruction of the library represents one of history's greatest intellectual tragedies. Countless works were lost forever. Yet the idea it embodied, that by combining the world's wisdom, we could map the cosmos, never perished. In our modern world, we navigate with satellites, tell time with atomic clocks, and plan our years with digital calendars. We live in an age of technological precision, seemingly disconnected from the ancient arts of skywatching. Yet, the legacy of our stargazing ancestors is woven deeply into the fabric of our daily lives. Look at the structure of our week. The concept of a 7-day week is a direct inheritance from the ancient Babylonians, who dedicated each day to one of the 7 celestial bodies they could see with the naked eye: the sun, the moon, Mars, Mercury, Jupiter, Venus, and Saturn. Our time itself is measured in Mesopotamian increments. Their base 60 counting system gave us the 60-minute hour and the 60-second minute. Our 360-degree circle, the very foundation of geometry and navigation, is another gift from their celestial mathematics. The calendar that hangs on our wall is a refined version of the one developed by the ancient Egyptians. Their careful observation of the star Sirius, whose return to the pre-dawn sky heralded the annual flooding of the Nile, allowed them to create a solar calendar of 365 days, a foundational tool for organizing their agricultural society. Even the names we use for the stars and constellations are echoes from the past. The familiar patterns of the zodiac, Leo, Taurus, Scorpio, were largely codified by the Greeks, who built upon Babylonian traditions. Many of the brightest stars have names that reveal a later chapter in this story: Altair, Betelgeuse, Rigel. These are Arabic names, a testament to the Islamic scholars who preserved, translated, and expanded upon classical Greek knowledge during Europe's medieval period, forming a crucial bridge to the Renaissance. The fundamental perspective has, of course, shifted. We no longer see the will of the gods in a planetary conjunction or our destiny in a meteor shower. We understand the stars as distant suns, governed by the laws of physics. We have replaced myth with mathematics. But the essential human impulse, the driving force behind it all, remains unchanged. The desire to look up, to understand our place in the universe, and to find order in the vastness of the cosmos is a timeless human endeavor. The great telescopes of today, peering into the deepest reaches of space, are asking more sophisticated versions of the same questions that were asked by the builders of Newgrange and the astronomers of Maya cities. The night sky is the ultimate historical document, a glittering chronicle of human curiosity. In its light, we see not only the history of the universe, but the history of ourselves, forever connected to every ancestor who ever looked to the stars in wonder.